If you're watching this video, you already survived a viral pandemic. You know how dangerous viruses can be. But is it possible for your body to get tricked into thinking it's infected with a virus? And would that be dangerous as well? I'm Sharon Shaughnessy, and my thesis explores this question by looking at a genetic disease called myotonic dystrophy. Myotonic dystrophy is the most common form of adult-onset muscular dystrophy, but it has many symptoms besides muscle wasting. These symptoms are so diverse and seemingly random that it takes an average of 8 years for someone with myotonic dystrophy just to get an accurate diagnosis. Back in 1992, researchers discovered something interesting in the DNA of people with myotonic dystrophy, a region where the nucleotide CTG were repeated over 50 times, sometimes as many as thousands of times. Normally, the DNA in your cells is transcribed into RNA, which is essentially your cell's instructions on how to operate. But when this CTG repeat is transcribed into RNA, it just accumulates in the cells. Not only is it useless as a form of instructions, but it actually has many harmful effects in the body. So where do imaginary viruses come in? Well, if you remember from COVID-19, many viruses are made of RNA, so many in fact, that your cells have a type of antiviral security system to alert your body to any RNA that might be foreign. I hypothesized that in myotonic dystrophy, the repeat RNA can trigger this antiviral security system, essentially tricking the body into fighting a virus that doesn't exist. In the first step of my project, I searched papers and publicly available data sets for clues that this might be happening. Sure enough, I found signs of elevated interferons, the molecule your body uses to fight virus. While interferons are extremely helpful if you're infected with a virus, if their levels are too high for too long, it can be very harmful to your health. So how do we find out if the extra interferons in myotonic dystrophy are actually caused by the repeat RNA, and whether they're contributing to the symptoms? I'm currently looking at gene expression in several mouse models of myotonic dystrophy, some of which contain the repeat RNA, and some that model the disease in other ways. If my hypothesis is correct, I'll find elevated interferons only in the mice that contain the repeat RNA. In these mice, we can begin to test treatments to turn off that antiviral security system and see if symptoms improve. There still isn't a cure for myotonic dystrophy, but I hope that my project will bring us closer to finding a treatment that can bring relief.